I'm Dmytro. I'm tech lead in Lohika. Usually when I introduce myself, I say that I make this world a little bit better with mobile apps, and I would like to explain you why. So just take a look at these screenshots. This is an application. That's a project I work on. So I want to say that sometimes mobile apps become more than just regular mobile apps when it comes to human health. It's another type of application that they're not only for business, but they are for people, for children. We help to improve the quality of life for children with hearing loss, to make their life a bit comfortable, so that they have the opportunity to watch a movie, study in the classroom, listen to music, walk safely outdoors at least, and get remote support from their doctor. But why this type of application is different? Because they called medical devices. Here you can see the definition, what is software as medical device. The definition provided by Food and Drug Administration in the United States. That's very, very serious, guys. The FDA is responsible for protecting and promoting public health through the control and supervision of food safety, dietary supplements, blood transfusions, medical devices, etc., etc., vaccine, cosmetics. Software as medical device, it means that it's a software that performs one or more medical functions. It can be directly integrated in the piece of hardware, or be like software just pretends that it performs a medical function, like a remote control. It's very, very interesting. There's a regulation and standards for medical devices. The first standard, the 13485, was published for the first time in 1996. The current ISO edition was published in March 2016. It has named medical devices, quality management systems, requirements for regulatory purposes. It represents the requirements for a comprehensive quality management system for the design and manufacture of medical devices. Along with that, it comes another ISO 27001. It contains a set of policies and procedures for systematically handling company sensitive information to minimize risk and boost business continuity by limiting the impact of security breach. It provides requirements for documentation and implementation. It's very important. Also, it includes internal audits, continuous improvements, and preventive action plan. So the flow is pretty similar to that you see on the slide. So you follow the standard, then regulators approve that, and only after that, when your source code approved, your application itself approved, and all the supplemented documentation approved, only after that your medical device can reach the market. So there are coding standards for medical device development. So the idea behind the coding standards is very simple. There are sets of rules that give software developers guidelines relevant to writing code. So irrespective of any safety or security considerations, coding standards help ensure that code is written with consistency and uniformity, and it's easily readable by everyone in the development team. It's also very, 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 very important. So it helps to reduce bugs and security vulnerabilities while creating some kind of quality of the code, which includes static analysis, and we'll talk about it in a moment. Also, cybersecurity included, and secure coding standards. They're important because they help to ensure that software is safeguarded, and what's more, the secure coding is wanted for every development team, regardless of whether it's code for mobile devices, for personal computers, or for servers, etc. Doesn't matter. Also, There's a guidance provided by International Medical Device Regulators Forum, and the purpose of that is to accelerate international medical device regulatory harmonization and convergence. Let me just skip this slide because there are a lot of text, and I believe you get the point. So static analysis, what is it? It's also called static code analysis, and it's a method of computer program debugging. It's done by simply examining the code without executing the program itself. This process provides an understanding of the code structure and can help ensure that the code adheres to industry standards. I believe each of you faced a situation when your pull requests or merge requests commented like, please remove these two spaces or something like that. Code formatting and code style is like a personal hygiene. It's very important. It's very simple, but really important. You don't like to get such comments. You hate to add such comments to others. And when you submit a pull request with some code, you would like that other people were focused on the issue that you solved, on the feature that you delivered during the code review, and not on the format or style. You'd like to focus on something that really matters. You enforce global formatting conventions, and you include company-wide rules by default. Each team can have its own set of rules. So sometimes to fix such formatting issues, you have to change branches to fix a single formatting error in your merge request, or it's demotivating. So developers think about ways to automate such things, to add some automated tools to your build chain or to CI server, and focus on complex issues that really worth it. So a little bit of history. When we used to write our applications in Java, what tools we had? We used PMD. PMD is a great tool. It finds common flows like unused variables, empty blocks, some unnecessary object creations. And it supports not only Java, but JavaScript and many other languages. The next tool is CheckStyle. I love CheckStyle. It's super tool. It analyzes source code and looks to improve the coding standard. It verifies the source code for conventions like imports, headers, white spaces, formatting, and it automates the process of checking Java code to spare humans of this kind of boring but still important task. So it's highly configurable. You can configure everything, and you can support any coding standards, including the popular like Google Java style or style from Suncode. And also it produces very beautiful reports. They're amazing. The next tool that we had with Java, it's find bugs. Unfortunately, it's been 6 years. It's not supported because the latest release was in March 15. So find bugs analyzes Java bytecode. So it focused mainly on classes, and it looks for any design flows, looks for potential bugs, and it needs compiled code to work around, and eventually it will be fast since it works on bytecode level. So the categories that it finds issues: correctness, dodgy code, multi-threaded correctness, and internalization, everything. That was a really cool tool. Unfortunately, it's not supported anymore. And the last one, and my favorite, is error prone by Google. So the tool is amazing because it catches as much mistakes as possible before they end up as bugs in production and cost you time and money for your customers. And with their prone, there's an interesting story about how this tool helped to find a bug in concurrent hash map in JDK. So the bug was the order of constructor parameters in some classes. They were switched. So, but this mistake was benign because it happened twice, and like one mistake by one mistake, and they compensated, and two wrongs made a right. So there was a bug, but it was impossible to reproduce. It's such a fun fact about that. But error-prone found it, and it was fixed. So nowadays, we are not that ancient. We do not use Java anymore. We use KotLand. So what do we have with KotLand? So this guy doesn't require special introduction. It's Android-linked static analysis tools, and that's intended for analysis of Android code. However, in fact, even within Google, it's used to analyze not only Android code, but Java classes and KotLand code. Focused on Android, mostly it can analyze not only KotLand and Java code, but it can analyze Gradle files, resources, ProGuard files, and many others. So even if you do not, even if you have a non-Android project but KotLand project, you can add Android link to it, and it will find something. At least it will try. Not all rules will work, of course, because still it's really powerful tool. And it's very easy to write custom tools for Android lint. Unfortunately, the API is 10 years as unstable. So as of today, it's beta. Market is beta, and some APIs are more stable than other. However, you can use it normally, but bear in mind that after the next upgrade, some of your custom rules may be broken. The next tool is KotLand. It's a linter with built-in formatter. So with KotLand, what I love with KotLand, it's you don't have to make any decision, nothing to argue about, and it just applies the official Android KotLand style or official KotLand style from KotLandlang.org. But you can add your own rule sets, and it respects editor configs. And running KotLand generated report can show you the places in your code that are not broken but formatted in the wrong way. So you can run either check or the formatter itself that will find and try to fix all the style violations so that you don't have to do it by hand. And it generates pretty beautiful reports, and you can write your own reporters to tweak that stuff and create the style of report that you'd like. And my favorite one is Detect static analysis for KotLand language. So Detect works only with KotLand and operates with a syntax tree provided by the KotLand compiler. Finds code smells in your code, and also generates reports based on lines of code, cyclomatic complexity, etc. And it's very extendable. And later I will show you how to write rules for Detect as well. Let's go ahead. Last but not the least, there are three tools. I placed them on the one slide because first of all, they either not all free or have limitations depending on the operation system they're running. These are not just a CLI tool. It's very powerful framework. It's automated all-in-one mobile application. They have a lot of features. It can do penetration testing, it can analyze malware, security assessment framework capable of performing static and also dynamic analysis. It supports not only source code, but mobile app binaries, and they are easy, can be integrated with your CI/CD pipelines. And they have dynamic some of them have a dynamic analyzer that help you to perform some security assessment and instrumented testing as well. I mentioned PSI. This is PSI is program structure interface, just literally. It represents the hierarchy of elements that call trees. The single PSI file itself, it's a PSI element, it can contain other elements, so it behaves like a tree, but this tree represents the code, the structure of your code. Let's go ahead and see this piece of code. This is just a regular object. This has a function and a constant property. So I don't know if you see the cursor, but on this example, we can see that the whole KT file.
Yeah, we see the cursor.
Excuse me, you see it?
We can see the cursor. That's fine.
Oh, great. So I can show on slides. So this KT file, the whole file, and it has package directory, which is here. And then it has dot qualified expression, which is this one, and this qualified expression has left member and the right member. So left one is called receiver, and the right one is called KLE, and this is also a dot expression. Next, we have object object declaration, class body, property with its modifiers, private, const val, and so on and so forth. So if you want to write some custom rule, you just have to investigate the structure of that piece of code that you want to detect, and work with it and write your own parser. So let's go to demo. Let's see what I've got. I've prepared.
Now I think we should make interface a little bit bigger.
Definitely. We'll do that. So just open the demo classes. So what I'm doing, and let's make interface bigger. So please confirm you see it.
Yeah, now it's large enough.
So how to get the structure of the code? So download the plugin called PSI Viewer, or you can enable. Just let me show. You can enable the hidden custom property. This one.
Danger zone here.
Danger zone, yeah, but then you will get in the tool window the ability to view PSI structure of current file, and you can click in any place of your code and see its identifier or see its position in the tree. So it will help you to detect this piece of code. And the difference between actually PSI Viewer and this plugin, that one PSI Viewer gives you a bit more information. However, I like this internal viewer because it has this view, which sometimes can tell you more a bit about the structure of the code. So See, I selected a function, and it highlighted the all function, included its annotations and body. So I don't think we have enough time to see all rules. So I will show you just a couple. I was going to make some live stream, but I think it would be faster if I just open the code and show you and explain how it works. Is that okay?
Yeah, I think yes.
I believe yes. So let's open the demo number 1. So what do we see here? Here we have package some library, literally some library. Very often when you work on projects related to healthcare, very often customer provides you with his own library, his own SDK that has some secure protocol encapsulated, and that library communicates with his own devices without disposing you all of the internals. So what you usually want to do, you want to wrap that SDK in your data layer, in your gateway, in your repository, and you want to make sure that you don't use that SDK somewhere in fragments on UI, for example. So that's not very good. That's dangerous. So for that, we can create a lint rule for Android lint that will highlight you such pieces of code, and it will tell you that you use some customer library import. You can also suppress it, but how to make it work? So how to make it work for your own libraries if you face some situations. For that, I have created a module with my own lint check. I will skip the step of how to set up this. It's pretty straightforward, and if you're interested in this, you can Google it. You can find the official information how to set up a module. Let's focus on how to create a detector and register it so that your module could see and use it. So first of all, let's create a class that extends detector.
Let's make it bigger again.
Oh, let's make it bigger. Let's make it bigger again.
Yeah.
Is that okay?
Yeah, I think yes.
Cool. So let's extend detector and implement the interface source code scanner. What we are going to do, we are going to scan our Java files and find all the imports and highlight only the imports, start with some library. For that, this API lets us to set a filter and set the list of applicable UST types. UST is Universal Abstract Syntax Tree. It's some kind of representation of common code constructions that are similar for most of the languages. So in this case, we're going to filter only files and look for packages for imports in this file. So we override the method getApplicableUST-types and set list of file classes. Then we need to create a UST handler. It's an object that actually the actual visitor that will go through the nodes, and we are interested in node that is files. And then the code is pretty simple. When our detector visits file, it checks for imports. And for each import, it runs the function. It takes that import, takes its reference, and if that reference is not null, we check that it starts with the library package with this constant. It starts with some library. And if it found it, it reports the issue. Let's close a look. What is that? What is the issue? The issue is an object that contains just some plain data about ID of the issue. You will see in reports some brief description that's available for you like a short description and a longer description. And then you can specify the category of this issue. There are a lot of categories, so we can choose one. The one is correctness. We can set the name for that category and set the priority. Those numbers don't really matter if you don't measure some metrics. So on. Set the severity warning. If we set warning, then in the IDE will highlight you as a warning with orange. We can specify like informational or like error, and then it will be either green or red, or it can be even fatal. The difference between error and fatal, that they are both error, but you can suppress errors, but you cannot suppress fatal because they're related to the thing that's called vitals, and just keep it as a warning. And the last step is to provide an implementation which keeps the reference to the class and the scope. Since we measure, not measure, since we investigate in the Java files, so we use Java file scope. And if we run this, let's run it in my terminal. Just make it clear. And we can run command gradle lint debug. It will run this detector, and we'll spit out the, sorry for the colors, XML report for tools and HTML report for that are human readable. So I have it opened in the window. Just let me show you. Whoa. So there's our detection. There's a warning that some library import. You can dismiss it, or you can read information. So it's highlighted, and it has that long explanation. So there's a category, correctness, warning, and priority 10 of 10. So this is how it works with lint. It's pretty simple. The API is very rich, but you can do really cool stuff with it. And let's take a look at the example number 2. It's demo 2 for detect. So the rule I'm going to show you is the following. So as we already know, each team can have its own conventions, agreements, etc. So let's, for example, pretend that we need such a rule that all mutable shared flows must have this way. I believe most of you are Android developers, and you used to use live data in the past. So after migration to mutable to shared flows, probably you might want to keep the same behavior as live data had. So for that behavior, you have to ensure that your replay parameter is set to 1, extra buffer capacity is equal to 0, and on buffer overflow parameter is equal to drop oldest. So let's investigate this piece of code and detect and find some steps, and let's define what we are looking for exactly. So for that, I'm going to use my helper PSI viewer. So the step 1, we are going to find all invocations of this method mutable shared flow. If we open the plugin, we'll see that this is a call expression. Okay, let's find some call expressions. Let's go to my module called detect checks, and we'll see that structure and the principle is pretty much the same as for Android lint. The differences are minimal. So we have have to register a rule set, which we call KotLand rule set.
And it's time to make it bigger again.
Oh, thank you for reminding me. I have a big monitor, and it looks big, huge for me. So I should set the name for our rule set. Should set name for rule set, which we'll specify in our config detect YAML just here. So the name is KotLand. We set is active, and there are also two rules. And this rule I'm going to show you how I implemented this. So we provided this rule set and just create instances and register them in the rule property. So the rule is called shared flow as live data. Now the rule is similar to detector from Android link. To implement your own rule, you have to override the necessary property called issue. Let's make it bigger again. So you should specify the shared flow as live data ID for this detect YAML, like here. Set the severity warning, set some description, and say that fixing this will take less than 5 minutes. So we agreed that we are looking for what? We are looking for reference expressions. What type of class we should visit? Let's click this property, and we'll see that this call expression has the type of KT call expression. So let's visit all call expressions. This rule has a lot of visit methods. So just you can see how many visits. You can visit everything. You can visit every single piece of code. It's pretty cool, but we're interested only in KT call expression. What else? We visited. In step 1, we should check that that method has the proper name. The proper name is mutable shared flow. So let's filter everything else. So check the name. I have some constants already prepared for that. I know the name of the method, I know the name of parameters, and I also prepared the error messages that we will report for each code smell we find. So let's collapse everything else. So first step is check that we looking for mutable shared flows.
And it's time to make it bigger again.
Ooh. And we can close this. So we found check the expression, reference expression, and check the property text. And it should be mutable shared flow. The difference between detect and Android Lean, that detect works with strings mostly. So you cannot resolve a class, for example, or resolve a class. So all you can do is to check strings and work with them. The implementation probably not the most efficient, but definitely it's very simple to write such detections. So if we found this method, if we found mutable shared flow method, let's check for parameters. Step 2, check the number. So our rule says that we must have all the parameters set, all 3. So then step 2, we check the number of parameters. We check the size of value arguments, and if it's not equal to 3, we report code smell. We pass in parameter of the expression, so that to highlight that expression, we'll take a look at the report generated later, and we'll say that all parameters values must be set. Okay, if it's fine, if we have all 3 arguments set, let's iterate over them and Now step 3. Let's check that argument have names. For example, if we remove this replay parameter and open the PCI viewer, we'll see that this value argument has only integer constant. But for example, the next extra buffer capacity has value argument name. So this one violates our rule. So let's reflect this in our code. So we'll check for argument name, and if it's null, we report code smell and specify the message. We highlight that argument and say that this call argument must have a name. Okay, if it's not null, we go to step 4. We check that arguments have proper values set. Proper values means that replay must be set to 1 and extra buffer capacity must be 0. So let's visit all our methods and check. If it's method replay, let's check if it's a constant expression. Constant expression is just 1, 0, just a digit like here. So we know because our PSI viewer tells us that we're looking exactly for this piece of code, which is integer constant. Integer constant is represented by class constant expression. So we check for that type. So if our arg expression is context expression, then we check if it's equal to 1. If no, we just report the code smell with the proper message that the value of replay must be equal to 1. If it's not a constant expression, it can be reference expression, etc., we report a code smell because we are forcing our rule to use only constants. Absolutely the same for the second parameter, extra buffer capacity. The difference only that we check it should be equal to 0, and code smell will have a different message. And a bit more interesting part is about this enum value, buffer overflow drop oldest. So what its representation? It's a reference expression, dot qualified expression. So let's check for all dot qualified expression. If it's dot qualified expression, we should check the receiver and check the receiver name. And receiver name must be buffer overflow. And the right side called callee expression, if exists, it should should be named drop oldest. If this not true, we report code smell. And one more case to check is the case when you, for some reason, added import for that. So it's not a k dot expression anymore, but it's reference expression with the identifier that it's called drop oldest. So we can cover that case in our rule as well and allow that. So we check argument expression text that it equal to drop oldest. Otherwise, we report code smell. And for all other cases, we also report code smells because all other cases does not satisfy our rule. So all steps passed, and we can run this. But before we run that, we just open the box of Pandora and we'll do this very, very bad thing. I will uncomment all the examples I prepared for this check. Instead of writing tests, I just created many shared flows with different set of parameters. So we can run the detect rule and see the report that we'll get. So our build, of course, failed, and we got a lot of this shared flow as live data issues reported. We can read the report, just open our library module And in the build folder, in the report, there's a detect. We can open it. I have already opened on my another tab, and I'm gonna show it to you like this. So you can see the report of detect. It's how many properties, how many functions, but we're interested in findings. So let's ignore that. We don't have time for that. So our shared flow as live data rule reported 15 times. So this
It would be cool to make this large too. Yay!
Thank you, thank you, thank you. So we see that this rule is violated by this parameter, and we see the description that this call argument must have a name. This one also must have a name. What else? Oh, this one is also violated. On buffer overflow must be set to drop oldest, but it's set to drop latest. So we broke our rule. Buffer overflow suspend, it's also broke our rule. Not all parameters set here, only 2 of them, only replay on buffer overflow. So you can see that the rule works. So you can create your own one. And let me get back to my presentation. So we can continue. So the demo is over, and what I wanted to say that analyzers can only help, but they will never do your job for you. So analyzer is not a panacea. So be careful and don't rely on tools. A few links, just the links to official documentations for Detect, KotLand, and Android Lint, which is the most and the biggest API. It's really worth to look at it. So thank you.